So construction of PN junction diode. When a p-type extrinsic semiconductor is intimately joined with n-type extrinsic semiconductor, we get PN junction diode. So we know that in p-type extrinsic semiconductor, the majority carriers are holes, minority carriers are electrons. Along this we have negative acceptor ions. So these are the majority holes, these are the minority electrons, and these are the negative acceptor ions, right? Similarly, in n-type we have majority carriers as electrons, minority carriers as holes, and positive donor ions. So these are the majority electrons. Now these are the minority holes, and these are the positive donor ions. Now when this p-type is joined intimately with n-type, we get PN junction. But directly joining the two pieces will not form PN junction diode, because if we join directly these two pieces, then some irregularities produced in a surface film can give rise to discontinuities in crystal structure. So only what we will do means, we will take a piece from p-type and a piece from n-type. Now one half of the piece of a p-type is joined with the other half of the piece of n-type. So in such a way, the one half of the piece is joined with the other half of the n-type semiconductor. Now the plane dividing these two zones, we call it as junction. Junction means nothing but plane dividing the or separating the two zones. We call it as junction. Now let us see what is happening nearby the junction when p-type is joined with n-type. So in p, we know that majority carriers are holes. In n-type, majority carriers are electrons. Right? And along this we have minority carriers, electrons. Here minority carriers in n, holes. Right? Along this we are having negative immobile ions in p-type, positive immobile ions in n-type. Right? Now here what we did, we brought a positive type nearer to the negative type. So as usual, force of attraction will be there between these holes and electrons. So here what happens means, the holes crosses the junction and enter into n-type. So immediately it recombines with the electron present near the junction. So this is the recombination of hole and electron. So when hole and electron, that is positive negative charges combine, what happens? They become neutral. Similarly, an electron crosses the junction and enter into the p type. So immediately that electron recombine with the hole. What is happening here? Recombination is taking place between electron and hole. So what happens? They become neutral. Now this process of motion of holes into n type, electrons into p type, we call it as diffusion. So what is diffusion? The motion of holes into n type and electrons into p type, we call it as diffusion. Now due to diffusion, what is happening? When hole enters into the n type, it immediately recombines with the electron present nearby the junction in n side, become neutral. Similarly, when electron enter into the p type, it recombines with the hole present nearby the junction in p region and becomes neutral. Now this process continues. So then up to what extent this process continues? Up to what extent this process continues means, so here what is happening? When hole enters into n, it recombines with the electron. When electron enters into the p, it recombines with the hole in p region and becoming neutral. So this diffusion process continues until a space on either side of junction becomes free of charge carriers. Or we can say that this diffusion process takes place until a charge free space is formed on either side of junction. This diffusion process continues until a charge free space or region is formed on either side of junction. So this region we call it as depletion region. Means here in this region, or this region is depleted of charge carriers. So depleted of charge carriers means now nearby junction up to certain region, up to here nearby junction up to certain region in n type and p type, we will not find any mobile carriers. So totally we will not find any charge carriers. It is totally free with charge carriers. So a charge free space is formed, that we call it as depletion region. Now see how is the situation. Again I am drawing and showing. This is junction. This we call it as depletion region, which is depleted of charge carriers. Holes majority some negative immobile ions, electrons majority carriers some positive immobile ions, p type, n type. Now see what is happening. Here you see nearby junction in p region, we are finding what? Only negative immobile ions. Immobile means they will not move. In the region nearby junction in N, what we are finding? Positive immobile ions. Means they will not move from their place. They will remain there only. And whatever the holes and electrons are present here are recombined and became neutral. So only a charge free region has formed, that is depleted of charge carriers, called as depletion region. Now see what is happening. Now here what we are finding, totally negative immobile ions. What we are finding here, totally positive immobile ions. Right? Now what happens, let us see. Now hole from P tries to cross the junction and enter into N, but it cannot enter into N region. Why? Means nearby junction in N region, what we are finding, positive donor ions or immobile ions. So this positive immobile ions will repel the hole, that is, it does not allow the hole to enter into the N region. Similarly, an electron from N region, when tries to enter into the P region, so it also cannot enter into the P region. Why? Means nearby the junction in P region, we are having only negative immobile ions. So these negative immobile ions repel the electrons coming from the N region. That is, these negative immobile ions which are present in P region nearby the junction never allows the electron to enter into the P region. Similarly, the positive immobile ions present near the junction in N region will never allow the holes to enter into the N region. So in such a way, PN junction diode is formed. Why we are using the word diode? Means this is of positive type majority carriers, this is negative type majority carriers, electrons. So this is P type electrode, this is N type electrode. So only we call it as diode, two electrodes, positive and negative. And this layer or region dividing the two regions, we call it as junction. And these dotted lines which I indicated is depleted of charge carriers, called as depletion region. So now after depletion region, a potential barrier is formed in this depletion region only, we can say no. Now these electrons cannot enter into the P region due to this negative immobile ions. Holes cannot enter into the N region due to this positive immobile ions. That is, a potential barrier has developed in depletion region. Right? So this is the construction of PN junction diode.